Hello everyone, ଆଜି ଆମେ virus and structure and their properties पढ़िबा. So begin with my first slides. As you all know that virus is also a microorganism but is a collection of genetic code, either a DNA or RNA surrounded by a protein code, and virus cannot be replicated alone. It needs a host to replicate itself. The often they kill the host cell in the process and cause the damage to the host organism also. And the virus has been found everywhere on the earth. Researchers estimate that virus outnumbers bacteria by 10:1 in ratio because viruses don't have a same components as bacteria. They cannot be killed by antibiotics. Only antiviral medications or vaccine can eliminate or reduce the severity of viral diseases including AIDS, COVID-19, measles and smallpox. So this is very challenging task for nowadays. So COVID-19 pandemic is going on and we are suffer a lot. So there must be some such of solutions, but there is no such type of solution yet. So hope for the best for something new can come. Okay, so these are the some classifications of virus, and viruses are different types, different structures, having different components, either RNA is genetic material or DNA is genetic material. So number of viruses are more, and according to their DNA and RNA are fixed, but it depends on the what type of viruses is that, right? So these are the viral structures. Capsid, nuclear capsid is there, and envelope, spikes, capsids, and these are all made up of protein molecules. So these are the spikes, only carbohydrate protein complexes called glycoproteins that project from the envelope can be used to attach the host cell. So the spikes only helps to attach to the host cell, because a virus without host it cannot be reproduced. So it needs a host for reproduction. And properties of virus, as we all know that virus is a small, infectious, obligate intracellular parasite. It is not living. Viruses are chemicals and by themselves cannot reproduce. So a susceptible and permissive cellular host is needed for virus to reproduce, as I said before. And all viruses must make mRNA that can be translated by host ribosomes. Listen one thing. Viruses have the RNA and DNA genetic material. So one virus cannot have either RNA or DNA. A single virus either have RNA or have DNA. So in that case, if one you think of the COVID-19 virus, when we go for the RT-PCR, it is RNA is genetic material. So RT-PCR, in PCR only we can have the DNA segments with the last number copies. But if RNA is genetic material, then what to do in the RT-PCR? So it you all know, there is a central lemma procedure. So it transcribed first, then it have the complementary strand, and again it go with the PCS and it shows the number of copies. Okay, so that is called the RT-PCR. So these are some basic structures of viruses. DNA of RNA I said earlier, plus capsid protein, that is called nucleocapsid, that is equal to naked capsid viruses. You can see from the structures, glycoprotein is there, naked capsid viruses. These are the lipid membrane. These are the lipid membranes, and this is attached to the host cell. These are the enveloped viruses. So you see, this is there are the different types of capsid symmetry. This is a icosahedral and this is helical. So there are so many different types of or symmetrical capsid structures of viruses. So this is the attachment how the virus can attach to a host cell. See one by one this mechanism or attachment of replication, lock and key theory formula. It is just attached to the lock and key processes, and then it penetrate inside the host cell, and then resemble there. The fourth steps is very important. One step is disassembly. Then when it disassembles, then viral genome produces. Then after genome produces, the viral enzymes acts and the mRNA released out. And then translation, that is also important processes. In here, the mRNA converted to the viral proteins, as you see in this pictures. These are the viral proteins. So you can see the genome replications here. The viral genome here replicated in many numbers, and in these sides only the viral protein is still there. So they are assembled and they form a new type of viruses. So it release out. So this is your retroviruses, reverse transcription. So these are the different steps. And this is the important diagram of cellular infections. Alright, virus, it attaches to its host cells, it penetrates and transformation into a tumor cells, it multiplies with a different forms of the cells. One is tumor cell divisions, death of the cell and release of the virus, slow release of the virus without cell death, then virus represent but not causing harm to the cells. So these are the cellular infections caused by the viruses in various steps. So it reflects on the immune responses in cell-mediated immunity, important in recovery from viral illnesses, and antibodies important in the protections from repeated exposure. So these are the some of the definitions like viruses, obligate cellular parasites, including nucleic acids or DNA and RNA, surrounded by a protein coat, take over cellular machinery to reproduce themselves and eventually kill the host cell. So these are some different structures like Ebola viruses and smallpox viruses, HIV virus, hepatitis B viruses. So many numbers of viruses is present, and their microscopic structures are different. Their outermost structure also different. They are made up of protein molecules. So many numbers are viruses are there. Only some of the viruses are there, and their identification has been still left. So this slides this much. Next we will discuss about purifications, isolation and cultivations of viruses. Thank you.